Hi friends, welcome to my YouTube channel. Today I will discuss about DC generator. The function of generator is that always it converts the mechanical energy into the electrical energy. Always. Before to start generator, have to know the generator working principle based on Fleming's right hand rule. And one thing is that have to remember Faraday's law of electromagnetic induction. Now move to the point working principle of DC generator. Working principle of DC generator as based on Faraday's law of electromagnetic induction and Fleming's right hand rule mainly. That's why I am just discussing about first the Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction says that when a conductor is placed in a magnetic field, EMF is induced, and that EMF is the induced EMF is proportional to the rate of change of flux. That is the Faraday's law of electromagnetic induction. And number two, that is the main thing or the main based on that principle generator actually works. That is Fleming's right hand rule. According to that law, what happens if we hold right angle? If we hold the right hand like the first finger, second finger and the thumb all are right angles to each other, then the first finger, which indicates always the line of flux, and thumb, after that, after first finger thumb comes, thumbs represent the direction of motion of the coil. And number three move to the forefinger. According to the function of that finger is that we can find out the direction of current from that. So one thing, first finger represent the direction of line of flux, thumb represent the motion of the conductor, and the forefinger represent the direction of current. Okay, then move to the working principle. Now if we placed a conductor in a magnetic field, that's why there will be always north pole and south pole, and flux link from north to south like that. Now if we consider here or placed one coil here in that position, see, I am trying to draw actually the conductor, A, B, C, D, and the two ending point of coil is connected with a slip ring. Connected with a slip ring like that. After that, there are two brushes. Number one, suppose this one is positive brush and that one is positive brush and that one is negative brush. Load, here I have considered one resistance, suppose ml, as a load. Then according to this conductor, now we have to find out in which direction the current will flow. That is our target. Then now according to this law, suppose a ABCD conductor and which is rotating, that coil, ABCD coil is rotating in clockwise direction. To identify it, I am drawing here, it will move in clockwise direction like that, in that direction. So the first position here, this one is second, that one is third, here is 4, there will be 5, here is 6, there will be 7, here is 8, and that one is a 9. Now this one is 90 degree, the fifth position will be 180 degree, the seventh position is 270 degree, and last one is 360 degree. Now if we draw a cycle, then from there it will be very easy to check in which direction the current will actually flow. Now first, if we consider my hand like a conductor, that is first position, A, B, C, D. At that time, at position number 1, here the flux link with the coil, that is the flux link with the coil is maximum, that means in that position flux link is maximum. As flux link is maximum, according to Faraday's law of electromagnetic induction, the rate of change of flux is minimum. Rate of change of flux is minimum. That's why induced EMF is 0 here, because induced EMF is proportional to the rate of change of flux. That's why if we consider it is in a cycle, then this one is when the conductor in position number 1. Second, when it is moved, that is from one position to 2, like that, then at that time flux linkage with the coil decreases. That's why the rate of change of flux will increase and EMF will increase. Consider this position as a 2. Position number 3, this one actually, that means in 90 degree. In 90 degree position. At that time, flux link with the coil is minimum. At that time, flux link with the coil is minimum, but the rate of change of flux is maximum. That's why EMF is maximum. Okay. Same thing for fourth position. It will be now like that. That means for next quarter cycle, 90 to 180 degree, it will repeat once again like that. Next, when we move to next quarter half cycle, that is from 180 degree to 270 degree. At that time, what happened? Already it looks like that. At that time, it will rotate there in that position. So here also flux link with the coil will decrease and the rate of change of flux will increase. That's why EMF like that. At 7th position, like that. Okay. So here it will repeat once again for next quarter half cycle, means next quarter cycle, that means 270 to 360 degree. So if we draw the cycle, it looks like that. So the current direction, first one, that means flux link with the coil from north to south pole. The rotation of conductor, it is in clockwise direction here. So current is flowing like that. A, B, ML, C. Okay. For first one. For second position, the position looks like that. For next half cycle actually, First one is AB, ML, CB, and next one is opposite. Okay. Next topic I will start, that is the different windings of DC generator. Different windings is this armature winding actually. Armature winding is divided in two. Number one is wave winding and number two is lap winding. Both topic is very important. They are very important because problem may comes from both topics. Some tricky question and MCQ may comes also, wave winding and from lap winding also. But they are very easy. One by one I am moving to next point. One by one I will tell you. First, that is wave winding. According to that winding, armature winding, in that case it divides the armature conductor into always two number of parallel paths, and it doesn't depends the number of poles of the generator. I am repeating it once again. In case of wave winding, it divides the armature conductor always into two number of parallel paths, and it doesn't depends on the number of poles of the generator. Now according to, if we draw the wave winding, as I told, it divides the armature conductor into always two number of parallel paths. After that, brushes are connected and here is load are there. This one is positive brush and that one is negative brush. If the number of conductor Z number of armature conductor we use, then for example, for a 4-pole, one example, if we consider a 4-pole wave wound 30 number of conductors, it means that each path consists of Z by 2, current is there, armature winding, that's why IA by 2, like that, current flowing. So Z by 2, that means it become 30 by 2, which is equals to 50. Each path consists of 15 number of conductors. 15. Okay. Next, move to the lap winding. I think it is clear to all. Next is I am moving to lap winding. In case of lap winding, always it divides the armature conductor depends on the number of poles. Suppose if we draw it, in case of 4-pole DC generator, it divides the armature conductor depends on the number of poles of the it divides the armature conductor depends on the number of poles of the generator. That means the number of parallel paths actually depends on the number of poles of the generator. That means if we consider a 4-pole DC generator, it means that it divides the armature conductor into divides the armature conductor into 4 number of parallel paths. So same thing, there will be negative brush and there is positive brush. So each path consists of Z by P number of conductors. Z by P number of conductors. Current is flowing there. I. Okay. Next, I will move to the different types of DC generator. Different now types of DC generator. So I think lap winding is clear and wave winding is clear to all. The types of generator. First of all, two types. Number one is separately excited. Separately excited DC generator, and number two is self-excited DC generator. If we remember the circuit connection and if we actually remember the name, based on that the circuit diagram we can draw according to name. Separately excited means the field winding will be separately excited from other source of DC generator. In case of separately excited generator, the generator are those whose field magnets are energized from an independent external source of direct current. If we draw the circuit connection, it looks like that. I am drawing over here. Separately excited DC generator. This one is armature winding and the field winding is separately excited. The field winding, this one is separately excited from a other source of DC. Here current and their load are connected. This is the there will be brass also. This is the actual circuit diagram of separately excited generator. And self-excited means whose field magnets are energized from the generator itself. That is the basic difference between them. Separately excited means field magnets are energized from other source of DC supply, others DC source actually. And in case of self-excited generator, the field winding are energized from the generator itself. It looks like that. Now self-excited generator, there are three types of self-excited generator. Number one is shunt wound generator. Number two is series wound generator, and number three is compound wound generator. Now move to one by one. Separately excited generator, I think clear, and self-excited also clear. Now move to the different parts, different types of actually self-excited DC generator. Number one is shunt wound. Number two is series wound. And number three is compound generator. One by one, I will draw the circuit diagram. Shunt wound generator. In case of shunt wound generator, the circuit diagram will be shunt, the field winding, this one is connected here. This one is shunt field. Current is flowing. Here I and here I is. There obviously load will be connected. Load is connected like that. This one is the shunt wound. And next one is the series wound. Move to the series wound. In case of series wound generator, obviously from the name we can draw the circuit connection. Series means the field winding will be connected in series. That is the basic difference. There will be brass. Note. In case of series wound generator, the field winding is connected in series and load is connected. So as this one is the armature winding, current is flowing there, armature winding, and this one is the field winding. After that I amount of current will flow. Next move to compound. It is a combination of both series and shunt, and it is divided as long shunt generator and short shunt generator also. It is a combination of both shunt and series, both. That means if we draw the circuit connection, it looks like that. Series, that's why there will be series, and shunt also. If the number of turn is maximum, then this one is long shunt. Okay. If this one, same thing. This one is the shunt field. This one will be on the resistance, like that. There also shunt field, and this one is the series one. So this is long shunt. Load will be connected here, same thing. This one is the figure of long shunt. And next is, if we draw the short shunt, then it will be very easy for you to understand what is the basic difference between long shunt and short shunt. Load, there will be bus. This one is the field winding, that one is the field winding, and this one is the series winding. So next, DC generator types also done. Now move to one problem. Move to one problem. Suppose if we consider a problem where a shunt generator, suppose supply a load of, given data, supplies a load of 7.5 kilowatt. Supplies a load of 7.5 kilowatt at 200 volt. And the given data also have to find out the EMF when the armature resistance is 0.6 ohm, and also the field resistance is 80 ohm. RF is 80. Now according to that, if we draw the circuit diagram, it will be very easy for we to understand or to solve a problem. First have to draw. There is a load, here load, where load value is given, that means it is 7.5 kilowatt. Total voltage is given 200 volt. Armature resistance is given 0.6 ohm, and the field resistance is given, that is 80 ohm. Current will flow there. So what will be the first step? First step is that have to find out the current through shunt field winding. That is this one. That means this one is the shunt field. So first of all have to find out the current, that is ISH, which is equals to supply voltage is given. Okay, I am writing over here. All are given data. Here I am solving the problem. ISH, current equals to, voltage is given 200 divided by resistance 8. It becomes 2.5 ampere. This one, the first step. Second step is that have to find out the load current. Load current, how will we find out? The load value is given 7.5 kilowatt. So current is power divided by V, because next is have to find out the load current. Load current, which is equals to P by V. P is 7.5 kilowatt. Directly I am writing here kilowatt. So in watt, because it is given in volt, that's why I have to multiply with 1000 divided by 200. It becomes 37.5. 37.5 amps. Next, have to find out the armature current. The armature current have to find out. Which one is armature current? This one is the armature winding. Armature current. Armature current equals to I plus ISH. This one is I total. So armature current IA will be equals to I plus ISH. What is the value of I? That thing already we got. That is 37.5 from here. 37.5 plus this one 2.5, that is equals to 40 ampere. Next, what is our question? It was have to find out the EMF. That thing have to find out EMF. That's why we got already IA, armature current, this one. Now EMF, how we will find out? The armature voltage drop have to find out first. The armature voltage drop. Armature voltage drop means RA is given. IA already we got. So armature voltage drop is equals to VA equals to IA into RA. IA is 40 into RA is given, that is 0.6. So it's become 24 volt. Okay, it becomes 24 volt. Next, target have to find out the generated EMF, which is equals to terminal voltage. After that I am writing here the last step. See, EG have to find out, which is equals to armature voltage drop plus terminal voltage. So armature voltage drop, that is 24 and 200 plus 24, which is equals to 224 volt. So this is all about problem. Like that, like this problem, we can solve another problem also. For today I have done. Thank you all. If you like my video, click on the like button. Also, to get any update from my side, you can subscribe my channel also. Okay, thank you.